So, I'm Kian, one of the code gremlins. So, our job as programmers is to figure out how to control the robot. One of the most important systems that we have to control is the drivetrain. Most of our robots have what's called a tank drive, which is, you have two drive sides made up of some number of wheels, which can go between negative 100% and 100% each. So what becomes an issue, so then the drivers will give us some amount of how much they want to go forwards and how much they want to turn. So to go forwards using a tank drive, you would set both of them to go forwards. To turn, you would set one to go forwards and one to go backwards. So if I was to draw a quick table of what things would look like if we had forwards and turn, I'm going to draw these values between 0 and 1, between negative 1 and 1. So full forwards with no turn is going to have the right go to 100 and the left go to 100. Negative 1 is going to have us go to negative 100, negative 100. And then if I was to turn, I would set one to 100 and the other to negative 100 to get the most amount of turn I can. So what then becomes an issue is if I try to go forwards and turn at the same time. So if I was to just write out the values next to each other, so to go full forwards, I need 100, 100. Then to do full turn, I need 100, negative 100. So fastest solution to do this, we just add the two together. Because, I mean, each of them is doing what we want individually. Together, they should still do what we want. So that's set one side to 200% and the other side to 0%. This has two main issues. First one, we're going to 200%. For some unknown reason, the drive system cannot go to 200%. Ask mechanical. Second issue, we're not actually moving forwards. We're turning over one of our treads. One side is staying still while the other is going forwards as fast as it physically can. So we need to figure out how to solve both of those issues. So first thing we should probably do is figure out exactly what we mean by turn. As in figure out a way by looking at the drive side speeds and figure out how much we're actually turning. So the main way to do that is you look at the difference between them, or the range that the two numbers cover. So if I was to just add another column here, which we would call, I don't know, observed turn. As in we're looking at these and going backwards to how much we're turning. We would go 0, 0, 200. So now, if we actually take a robot and see how fast it can go at maximum with one side going full forwards and the other going full backwards, it's actually too fast. A driver can't control it, and we can actually only do this at a standstill. If we try and move at all, we'll be turning slower. So the ability to do this isn't actually useful. So the easiest way to do it is we just reduce how much we're turning by just, besides adding this, but directly adding the turn to the right and subtracting it from the left, we only add half the turn to the right and half the turn to the left, and subtract half the turn from the left. So that'd be 50 and negative 50. And then our observed turn would go down to 100, which is more controllable, but not perfect. So the thing is, this actually hasn't fixed our problem. It's just made the problem smaller. if we were to do the math again. So I'm going to first just show another way of visualizing the problem using bar graphs for each drive side. And so in this, so if we were to just go through the steps, and we had, so for full forwards, we would set both sides to 100%. Then, to then implement any amount of turn, let's go with full turn again, because that's fun. We would increase one side by 50% and decrease the other by 50%. So the shaded regions is just showing the area that's changed because of the turn. So now this is at 50%. I can't draw, and the other side's at 150, which you'll still notice is above 100%. So the way that we would go about fixing this is we just reduce both of them by how much one side's going over by. So that would take this down to 100 and this down to 0. So now suddenly the whole thing becomes that, and this one just doesn't change. So this still hasn't actually fixed the second problem that the first solution had. We're still not going forwards. We're still just turning over one side, but it did fix the first one, so that's some progress. So to then fix the second one, the solution is actually just reduce how much we turn by. If we set the maximum amount of observed turn to a lower number, besides like 100, to a more reasonable number like 70, then the right side would go to 35 and the left side would go to negative 35. So if I was then to do the math for this, the amount that I would try to go to that's too much would be 135%, and the other one would then go to 65% to compensate for the other side going over by too much. I am excellent at drawing graphs. So if we would then so we would try and set one side to 135%, the other would go to 65%. We would then have to bring it down by 35% because one side's going over by 35. That would bring this down to 30, if my mental math is doing right. And the other is going to be at 100. I did the mental math wrong. It should be like 25. No, 35? 35. 35%, final answer, I promise. So then if we do the math between these two and look at the observed amount of turn we're getting 65 amount of observed turn, and we're going forwards at 35% of our maximum speed by just looking at the minimum of the two, which still isn't quite what the driver wanted because they wanted to go full forwards and full turn, but due to reasons that I do not know, we're not physically able to do that. Ta-da!